Anyone? Anyone is going to see this screen now? Anyone? Please say yes or no, so that I will proceed further.
Yes, ma'am.
Okay. Now, in Power System, after clicking library browser, okay, simulate library browser of this. Okay, Power System list is there. Okay, here. In that we can see SimScape components, specialized technologies. Okay, in that we can see this is a connections: delta, star, floating neutral, grounded neutral, neutral port, open circuit. Okay, in machines, it is visible, na? It is visible or not? Various parameters I'm sharing. Okay. This is a synchronous machines. Types of synchronous machines are squirrel cage, wound rotor. Okay. Another next machine, synchronous machine. Okay. Permanent rotor or permanent magnet motor. Okay. These are the machines. These are the passive components. Okay. Time variable. Y connected variable load. Variable load means we are going to vary the load, what we have to take, a 50 watt load or 60, 100. Okay, we can vary by using these components. Okay, transformers, delta, delta, star, delta. Okay, these are the various transformers. Zigzag also is there. Zigzag transformer is also there. These have a specific application for high power converters, means we have to transmit high power. Okay, and we have to convert that power of high battery voltage. We can going to use this zigzag delta or zigzag transformer. Okay, now you have also seen that semiconductors in power electronics also going to use, like like IGBT is there, BJT is there, MOSFET, thyristor, diode. Okay, these are the various power electronics components, we can say semiconductors. Okay, these are we are taking these semiconductor devices from this semiconductor block. Okay, in these fundamental components, we have seen, or we are seeing this diode, GTO, gate turn off. Okay, IGBT, MOSFET. Okay, next sensors to sense what current or voltage, phase voltage. These are the sensors. Okay, sources, battery source, current source, voltage source. These blocks are here in sources. Okay, in switch gear also we have seen what type of circuit breakers or switch gears, switches we are have used. Okay, we can take from this fundamental components. Okay, from this we have seen this blocks in power system. Okay, in electronics, here semiconductor devices are there, current limiter. If we have to take n channel IGBT, n channel MOSFET, we can take from this electronics list. Okay, in sim event. Okay, In this simscape, foundation library is there. You are going to see this. In that foundation library, electrical first block is of electrical, second hydraulic, magnetic, mechanical. Yes, who is in that electrical component? We can take capacitor, electrical reference, gyrator, inductor, infinite resistance, mutual inductor. Okay, thermal resistors. These basic components we can take from this foundation library. From that foundation library, after that electrical, after that electrical components means basic components, capacitor, inductor, diode, resistor, infinite resistance. Okay, mutual inductor, mutual or variable capacitor, thermal resistor. Okay, you can take. Now this is electrical sources. Okay, these are the electrical sources. This is the AC current source. Okay, control the current source. Okay, I think in power electronics you have seen, or in network also, current control the source, or current control the voltage source. Okay, these are here. You can see current control the current source, current control the voltage source. Okay, DC current, DC voltage. Okay, these blocks we are going to take from these electrical sources to build a model. Okay, these electrical parameters we can take from Simscape. Okay, I'm again repeating from Simscape. Okay, Simscape. After that, electrical. No, first foundation library, electrical elements, sources, sensors. From that we can take. Okay, and if we want to see output of any block like current source or voltage source or current voltage, we can take display block. Okay, this is a floating scope, output port scope, stop simulation, terminator. At what uh, at what we can say at what time we have to terminate the signal. This is a terminator. Or to file, means from which input we have to take this file to up to what. Okay, to workspace. Okay, this is a XY graph. Okay, in that, after that sources. Okay, in signal system or in power electronics also, you have going to use this sine wave, step wave. Okay, pulse generator is mostly used in power electronics. Okay, to generate pulses. Wait a minute. Okay, um, after that, this is a signal generator, sine wave. Pulse generator also is there. Ground in electrical power system, or to perform any electrical model, we have to take we have to must take ground. Okay, ramp, signal, step signal, sine wave. Okay, waveform generator. Okay, these are the sources. Okay, we can say input sources also. Ports. Okay, these are the ports, various ports. Okay, after that, maths operations. Okay, in control system, gain is there also. Okay, gain is there. What is meant by gain? All of you know. Okay, after that, some summation, subtraction, we can take it from this math operation. Okay, divide. Okay, this is a sum, subtract. Okay, sine wave, sine. Okay, we have to take. You can also search on this current source by clicking in this search box. Okay, all of you are going to see this search box. In by putting this current source, we can see current source is there voltage current source or current controlled current source, DC source. Okay, DC current source, AC current source. Okay, various sources we have seen this, or we can also take voltage sources. These are the voltage sources. We can see DC voltage source, simply voltage source, exponential voltage source. Okay, by putting in search box, we can take. Or if we have to take MOSFET, okay, simply put it on search box. We can see this MOSFET, IGBT diode MOSFET. Okay, if we have to take scope, you can put it on scope. Okay, you can see these scopes. Okay, time scope, vector scope. Generally, we are using this scope displaying of output signal or output voltage, current, what parameters we have to want. Okay, here we can see from, if we have to take one value from one block, okay, to that block. Okay, from one block to another block. From here we can see from block is there. Simply we can take add to block model, and by putting this, we have to type it in Windows. Okay, untitled Windows or comment box or command window. Okay, from this we can directly generate that value from the another value. We are not going to connect this or any blocks. Okay, this is a from block or go to. We have to go to another value or block. This is a go to scope. This is a XY graph. We have to see a graph of any quantity, like we can see torque and torque and speed also their characteristic is there. How to plot? By giving value to that block, we are going to see xy graph, okay, directly. Okay, these are the scopes. If we put register, okay, here we can see various types of registers we can see. Register, thermal register, variable register. Okay, we can see these are the basic blocks from the Simulink library or library browser. Okay, we can also type user defined functions. Okay, if some mathematical equations are there or some derived equations are there, we can put it on user defined functions. Okay, all of you are getting?
Yes, ma'am.
Okay, these are the various parameter blocks, okay, which we are going to see. Our first practical is a active and power flow analysis of active and reactive power. Okay, from next Wednesday we are going to see practicals. Okay, first practical is of simulation of power flow analysis of real and reactive power. Okay, we are going to see real and reactive power in HVAC system or in HVAC transmission system. Anyone knows what is power triangle? Okay, active reactive power. Anyone?